Mayuri, write your seat number. Yash Linge, write your seat number. So it is already 11:11. We will start. So in the last lecture, we are discussing about the polyester part. I think this is also completed. But once again, I want to discuss these polyesters because many times it is asked for 2 marks. You know this ester linkage, that is the C double bond O linkage. Polyesters are also called as dacrons or terylins. And this is a condensation polymer. Always we have to see the example, then we'll understand how the esters are prepared. So these are the two different monomers. It is a copolymer, remember. Copolymers, these are the polymers prepared with different types of monomers. This is different and this is different. This is ethylene glycol. Ethylene glycol is also called as ethane 1,2 diols because two OH groups are there. That's why it is called as diols. And this is a terephthalic acid. This is a dicarboxylic acid. See here, we can see clearly here at the first position, COH group is there. This is second position, this is third position, and this is fourth position. So this is 1,4-dicarboxylic acid. It is also called as a terephthalic acid. Instead of this terephthalic acid, we can use here dimethyl terephthalate. The structure of dimethyl terephthalate is instead of this hydrogen, only CH3 group is there. So remember, we can use here dimethyl terephthalate also. Then I want to explain how these esters are prepared. How these esters are prepared. So when these glycol and terephthalic acids, these are mixed together, and the temperature is 420 to 460 Kelvin. In presence of this catalyst is used zinc acetate antimony trioxide catalyst. At the time of board exam, if you forgot to write the catalyst, then it is also okay. So it is not compulsory to remember the catalyst. If you write the name, then it will be okay always. And if you didn't write the catalyst, no any examiner will deduct your marks. But the here we have to write the reactants correctly and we have to write the products correctly. Also the byproducts are not important in some reactions. If you forgot to write the byproducts also, then it is also okay. So how this condensation takes place, I want to explain. Always remember this OH bond of this carboxylic acid is removed because this alcoholic OH, oxygen having the lone pair of electrons, is always attacks on the this carbonyl carbon. So this oxygen having the lone pair of electron, it always attacks on this carbonyl carbonyl, and this OH and this hydrogen is removed, and these two molecules get joined together. So this is nothing but only these two molecules are joined together. It is called as a terylene or dacron. This is having many applications. This is used for making the wrinkle-free fabrics. This is mixed with cotton. That is called as blending. When it is mixed with cotton, the material is called as a terrycot. When it is mixed with wools, the material is called as terrywool. It is also used for glass reinforcing material in safety helmets. Then this is also the polyester, polyethylene PET bottles. You know, we are using the PET bottles in our day-to-day life, the mineral water bottles. All this is made up with PET, and this PET is nothing but the polyethylene terephthalate. This is a long form of this PET. Remember, polyethylene terephthalate. This is called as PET. Most common, it is a thermoplastic polymer. You know what is meant by thermoplastic and thermosetting. There are two types of polymers. Already I explained. So I am not explaining again what is meant by thermoplastic. It is having the specific property. When these polymers are heated, they become soft, and when these are cooled, they become hard. So these can be reused or remolded. And then this polyethylene terephthalate is also used for making bottles, then jam packaging material and containers. Then next ester is polycarbonates. Now these are this is having also many applications. This is used for it is used in CDs. Whatever the CDs or DVDs we are using, it is made up with this polycarbonate material. Then all the bulletproof glass. Remember, this is a very important use of this polycarbonate. All the bulletproof cars, glasses are made up with these polycarbonates. Then car headlamp in car headlamp lenses, it is used. Then baby feeding bottles. Then roofing, for roofing purposes, it is also used. And then eye lenses. This is asked for, I think, JE or NEET. It is asked which polymer it is used in eye lenses. So remember this polycarbonate. Then this phenol formaldehyde and related polymer part, this is a deleted or non-evaluative for this year 2021 due to COVID-19. So this will be not asked for board exam, but I want to mention one thing. This is a very important polymers for the CET purpose. One question will be asked on it. So read it at your home. I have given already the notes of this one. This bakelite and what is meant by this Novolac. Board, for board exam it will be not asked, but for the CET purpose and JE purpose it is used. This is also non-evaluative melamine formaldehyde polymers. So I am not explaining this. Those students who are preparing for the competitive exams, please read carefully. Now I am coming to this natural rubber. Yes, this will be asked for your exam. What is mean by natural rubber? Say, rubber is a natural polymer. Actually, it is obtained from nature, and it is having the elastic properties. Rubber having the elastic properties, it is a natural polymer obtained from plants. It is also termed as elastomer. Already I explained the term what is meant by elastomer. The elastomers, these are the elastic polymers. They are having the property of, these are very soft and stretchy, we can stretch it. And natural polymer also having the variety of uses. So how it is prepared? It is manufactured from the rubber latex. Now see, what is this rubber latex? It is a colloidal mixture of rubber and water. And what is a colloidal dispersion? It is explained in chapter number 7 in 11th standard. What is meant by colloids and colloidal dispersion? This part is explained. So I am not explaining again and again. So rubber, it is obtained from rubber latex. Rubber latex is colloidal dispersion. And this latex is actually obtained from the bark of rubber trees. There are many trees found in India, specific area that is called as in Kerala, then in Sri Lanka, Indonesia, Malaysia, South America. These rubber trees are found. So from the bark of the rubber tree, this latex is obtained, and the rubber is prepared. So natural rubber may be considered as a linear polymer of isoprene. Remember, it is a linear polymer of isoprene. Isoprene is nothing but, the IUPAC name is written in the bracket here. It is a 2-methyl 1,3-butadiene, and it is also called as cis-1,4 polyisoprene. See the structure, then it will be more clear. See, this is called as isoprene. What is isoprene? I will explain. Another name is 2-methyl 1,3-butadiene. So this is carbon number 1, this is carbon number 2, this is carbon number 3, and this is carbon number 4. There are 4 carbons in the straight chain. On the second carbon, methyl group is there. That's why it is a 2-methyl, and 1,3-butadiene indicates, buta indicates there are total 4 carbons. Diene indicates there is a double bond, 2 double bonds on carbon number 1 and carbon number 3. That's why it is called as 2-methyl 1,3-butadiene. Always remember, for the board exam, this question will be asked for 1 mark in question number 1. For MCQs or answer in 1 sentence, they can ask, draw the structure of natural rubber. So we have to draw the structure of natural rubber, means we have to draw this 2-methyl 1,3-butadiene. Actually, this is a very large structure. These isoprene units are joined together. See, this is one isoprene, this is second isoprene, this is third isoprene, and this ring will be, this chain will be extended to this both sides. See this arrows means these CH2, 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 CH2. This chain will be extended to this side, right hand side also, and left hand side also. So this is a very large structure shown, but this is a single unit monomer. It is a isoprene unit, and this is a natural rubber having the n number of isoprene units are there. So always remember, this is the cis structure. See this CH2, this is the carbon-carbon double bond. This CH2 and this CH2 are on the same side of this double bond. So this natural rubber, remember, it is a cis 1,4 polyisoprene. And one question, one information I want to share with you. This is asked for the NEET exam or JEE. I didn't remember, but this is asked for competitive exams. What is trans 1,4 polyisoprene? Cis 1,4 polyisoprene is a natural rubber, and what is this trans? Trans 1,4 polyisoprene means this CH2, CH2. These are on the opposite side. This in this natural rubber, see this, both the CH2s are on the same side of the double bond, and in case of trans 1,4 isoprene, this CH2 and this CH2 will be opposite side, and this hydrogen will be above. So this trans 1,4 isoprene always occurs naturally. It is called as gutta percha. This is as for exam. What is the name of trans 1,4 isoprene unit? This is I am giving extra knowledge to you because this is not included in your textbook, but it is related to this natural rubber. So I am giving this information. Remember, for the competitive exam, CET exam or NEET and JEE exam, this is important, which is having a zigzag stain structure fitting in one another. It is a non-elastic and crystalline. See the difference between natural rubber and this gutta percha. When it is cis, it is having the elastic properties, and when it is trans, it doesn't having elastic properties. Remember. Then next one is a vulcanization rubber. Make a note there. It is very important for 2 marks. Write a note on vulcanization of rubber. Many times it is asked for short notes. So what is vulcanization? I will explain. To improve the physical properties of natural rubber. Means natural rubber, it is doesn't having the tensile strength, too much tensile strength, and it is do not having the shining. So for the improving the properties of this natural rubber, the process is process of vulcanization is carried out. The name of the scientist Charles Goodyear discovered the process of vulcanization, and with this famous name of the Goodyear, one tire company is also given the name of this Goodyear tires. The process by which a network of crosslinks are introduced into the elastomers, it is called as vulcanization. So vulcanization is nothing but in natural rubber, these crosslinks are introduced. So what is meant by crosslinks? Already explained when we are discussing about the structure of polymers. There are linear structure, there are branch structure, and there are also crosslink structure. So the process of introduction of the crosslinks in the natural rubber, it is called as vulcanization. So vulcanization, what is the role of vulcanization? This vulcanization enhances the properties of natural rubber. Means the properties of natural rubbers are increased. Which properties are given here? Tensile strength is enhanced, then stiffness is enhanced, then elasticity and toughness. All these properties are enhanced by vulcanization. So the sulfur vulcanization is the most frequently used process. Means sulfur crosslinks are introduced. And how this is done? See, natural rubber, it is mixed with 3 to 5% sulfur. Means 3 to 5% of sulfur is added in the natural rubber, and the mixture is heated to 100 to 150 degrees Celsius, and sulfur crosslinks are formed between this natural rubber, that is isoprene chains and sulfur. So how this is these crosslinks are introduced here. See, this is the structure of natural rubber, and these sulfur crosslinks are introduced. This is not expected to draw the structure. Remember, The structures are not expected at the time of board exam, but this explanation is important for 2 marks. So don't waste your time for remembering the structure. If you drawn the structure, then it is also okay. If you didn't draw the structure, then your marks will be not reduced, remember. So this is a sulfur crosslinks are introduced in the natural rubber, and such process is called as vulcanization of rubber. Remember, this is important for 2 marks. It is written here, short note for 2 marks. Then preparation of some synthetic rubbers. You know, synthetic polymers or synthetic rubbers, these are purely man-made. The word synthetic indicates it is purely prepared in laboratory. So first one is neoprene. This neoprene is prepared from the chloroprene. See, what is meant by this chloroprene? It is 2-chloro-1,3-butadiene. Remember, this is again like 1,3-butadiene. Instead of this methyl group, there is only chloro. And in natural rubber, in isoprene, instead of this chlorine, methyl group is there. So this chloroprene, it is a 2-chloro-1,3-butadiene undergoes polymerization, and we get this neoprene. So how it is prepared? See this double bond, CH2C double bond. Only the double bond is shifted here. See in the structure, see the polymer and see the monomer, CH2 double bond, see here. See, only this double bond is shifted. See here. Only this double bond will be shifted, and this double bond will be shifted, and to the both sides the monomers are attached, and the chain will grow. The chain will grow across the right hand side also and the left hand side also, and the big polymer is called as neoprene. So this neoprene, it is used for the manufacturing of conveyor belts, gaskets. So see this one slide I want to show here. This neoprene having the uses, it is used for the preparation of laptop sleeves. So laptop sleeves means the cover of laptop. Then wetsuits, these are prepared with neoprene, and the small boats. These are the small boats which are used in uh, we can use it in tanks also. You can use it in for the boating purpose. Small boats are prepared. And then boots, these are the boots. So these are the uses of neoprene. It is asked for 1 mark or 2 mark question. So I'm not discussing the more part. I will take the next slide. This is a Bunaian rubber. This is Bunaian. It is also the synthetic rubber. It is prepared in laboratory. How it is prepared? See, again 1,3-butadiene and plus acrylonitrile. Now you are familiar with both the monomers. Acrylonitrile, it is also called as vinyl cyanide. This is vinyl group. Remember, CH2 double bond CH. And if cyanide is there, it is vinyl cyanide. If the OH is there, it will be vinyl alcohol. If the bromine is there, it will be vinyl bromide. If iodine is there, it is called as vinyl iodide. So this is vinyl group, remember. The vinyl cyanide, it is also called as acrylonitrile. Acrylonitrile and 1,3-butadiene, only these are joined together, and the polymer is called as Bunaian. So see carefully how these two monomers are joined together. Only the double bond is shifted here. See here, this CH2 and see this CH. See this double bond, it is shifted to here. If you want to join another monomer here, then 100% this double bond we have to shift. So this double bond, it is shifted here, CH double bond CH. See here, in the polymer CH double bond CH, then CH2, this CH2 as it is, and this is a CH2 CHCN of this acrylonitrile. See, CH2, CH and CN. This is CH2, CH and CN, and this double bond shifted here because we have to join another 1,3-butadiene molecule. So it is a very simple. Only it is a combination of these two molecules of monomers are joined together, and it is called as Bunaian rubber. So for the board exam or for the competitive exams, they can ask the identify the structure of Bunaian of the following. So we have to remember the structure also. Then where this Bunaian is used, it is having the special property. It is resistant to the action of petrol. See, petrol doesn't affects on this Bunayan. Also the lubricating oils does not affect. Also the organic solvents, means benzene, ethers, hexanes, they do not affect on this Bunayan. That's why these are used in making oil seals. See these such type of oil seals we are using in automobile engines. Why this is used? Because this Bunayan having the special property. Uh, it is not affected by the petrol, also then the lubricating oils and then organic solvents. So it is a very specific property, this Bunayan having the very specific property. These are also used for this making the printer rollers, and these rollers are also used for the different printers. Then also it is used for non-latex gloves. There are two types of gloves I want to explain here. Whatever the gloves which are used by the doctors, these are these are what you can say, we cannot use again and again, non-reusable. So non-reusable gloves are not prepared from this Bunayan, but the gloves which do not having the latex. Latex means that slippery part is not there. So such type of gloves, these are used for the electricians. These gloves are used by the electricians. And then another use is, it is also used in for the preparation of conveyor belts also. So this Bunayan having the different uses. It is used for making oil seals, then for the printing rollers, and then the conveyor belts, then the non-stick gloves. So if the uses are asked for exam, you have to write any, you have to remember any 4 uses. But in your textbook, the only 2 uses are given. These uses are already additionally I have given. So the question will be for 1 mark, remember, for board exam. Write the uses of Bunayan. We have to write any 2 uses. If the question is asked for 2 marks, then we have to write 4 uses. Then the next one is Buna S. This is called as styrene butadiene rubber. S stands for styrene and B stands for butadiene, and this is rubber, and it is also called as Buna S. So what is this Buna S? Again, we have to use this 1,3-butadiene and styrene. This styrene is a very poisonous gas, remember. This styrene is combined with 1,3-butadiene, and this polymer is called as Buna S. Again, the method of preparation of polymers is same. See, this double bond is shifted here, CH double bond CH, see here, CH double bond CH, and this double bond will be shifted. So it will be CH2, CH double bond CH, CH2, CH double bond CH, and then this CH2 and single bond again this CH2, and it will be converted into single bond CH, C6H5, and this dash. This dash indicates again another molecule of 1,3-butadiene will be repeated. Another, so the chain will be repeated to right hand side, and the chain will be repeated to this left hand side. Again, this side, again the styrene molecule is added. So what are the uses of this Buna S? I will explain. This Buna S, it is having the very strong mechanical strength is very strong, means these are very strong rubbers. These are having the abrasion resistance, hence it is used in tire industry. See, it is used in tire industry because of good abrasion resistance. Abrasion resistance means when the brakes are applied, it fits to the roads. That's why it is called as abrasion resistance. And then it is also used for the sealing and binding agents. It is having the better durability. It is also used for preparing these rubber sheets. So this is another synthetic rubber we discussed. So one question will be there for the board exam. It will be on Bunayes, or it will be on Bunayan, or it will be on neoprene. So my request to all, today we have to make the practice to write the structure of these polymers. What is Bunayan, Bunayes? This is a commercially important some polymer. This is the last part of this chapter. This is as for only MCQs, remember. So don't remember this monomer and polymer structure. What is important? Why this is given? This is for knowledge purpose given for the examination, because for the NEET exam, JEE exam also, one question will be there. The name, this is the name of the different polymers, and these are the applications we have to remember. So I will explain one by one, and then I have to start the new chapter, that is the green chemistry and nanochemistry. I want to start. So first one, this is the perspex, or it is also called as acrylic glass. This is used in lenses, then paint, security barrier, LCD screens, and then shutter register glass. The Bunayan already discussed now. This Bunayan also used in adhesives for the preparation of this. Adhesives means Fevicol or different Feviquick. This Bunayan is also used in rubber belts, conveyor belts, the shoe soles, then O-ring gaskets. This is already discussed. Then PVC pipes, polyvinyl chloride. This polymer is used for the water pipes preparation. Then raincoats. In raincoats, CA. This may be asked for exam. Which polymer used in raincoats? Remember, it is polyvinyl chloride. Then for the preparation of flooring also, this PVC is used. Then polyacrylamide. This polyacrylamide gel, it is used in electrophoresis. Then the next one is urea formaldehyde resin. It is used for the unbreakable crockeries, unbreakable dinnerware. It is also called as unbreakable crockeries, that is melamine and bakelite. Glyaptal, it is used in paints. Remember, this is as for board exam. I want to indicate one thing. This glyaptal is used for board exam, but many students neglect this table. That's why they lose their 1 mark. This glyaptal, it is used in paints and liquors. Then this polycarbonate. Already this is explained. This polycarbonate, it is used for the electrical and telecommunication hardware, food grade containers. Then thermocol. Thermocol, it is a non-biodegradable polymer. It is very dangerous for environment. It is made from artificial thin-walled beds of polystyrene. Uh, so it is given here also. It is non-biodegradable styrene, can leach when it is heated. So therefore it is banned. Why it is banned? Because this styrene is very dangerous gas. It is poisonous. So it is banned due to the two things. So this chapter is completed here. This chapter is included in the applied chemistry. It is having the 3 marks weightage. The weightage is not declared by the board, but I know the weightage. I have written this chapter, and also I have given the weightage of it for 3 marks and with option 4 marks. So if you prepared this chapter, you will get 4 marks easily, because the important things are in the chapters are the structure of nylon 6, nylon 6,6. This is a very easy chapter actually. That's why the weightage is given only 4 marks, and it is used for, it will be useful for passing and also for getting the scoring the marks. So today I request to all solve these questions which are asked for board exams. So this is my request to all. They write the chemical reaction used for the preparation of nylon 6,6C. This question is asked for 3 times: March 2008, 2009, 2010. So try to write these questions, and if you have any problems, then you can call me or you can message me. So this chapter is completed. Then I am going to start the next chapter. What is the name of the chapter is green chemistry and nanochemistry. Ten minutes are remaining. Within this 10 minutes, we will finish the introduction part. Also, I want to remind one thing. All the student, I think all the student got the reduced copy or non-evaluative copy of the textbook. So if you have any problem regarding the reducing syllabus or regarding the non-evaluative syllabus, purposefully I have prepared this textbook, and all over Maharashtra students are using. They are calling me daily. Some students from Nagpur, then Amravati, Akola, Buldana, then Satara, Sangli. These students are calling. So my request to all the students, please go through the copy, because in the PDF file, whatever the PDF it is given on the website, it is not up to the mark. But the textbook I have prepared, all the boxes are also given there. All the boxes are also marked. So the whatever the blue colored part, it will be not asked for board exam. Whatever the yes, this is a green chemistry and nanochemistry. This is chapter number 16. It is again having the 3 marks weightage with option 4. So these are 3 chapters. Chapter number 14, that is biomolecules, I will start at last, because this is a biology. Many biological reactions are and biological concepts are included in this chapter. That's why purposefully I kept this chapter behind. After this chapter number 16, again I will take the chapter number 13, that is amines. After amines, I will take the chapter coordination compounds, means one chapter from inorganic, one chapter from physical. I will make a combination of this. So this will be useful for us to set a paper of your terminal examination. Terminal examination will be for your 50 marks. I don't know the date when the exams will be conducted and when the college will started, but it's our duty to complete the at least 10 chapters. So this chapter is for 3 marks, and with option it is for 4 marks. Newly introduced chapter. See, this chapter is newly introduced in the syllabus, so we will not get any types of notes or any types of questions which are asked for previous board exams. In this chapter, uh, see why this chapter is included, because we have to make the awareness of green chemistry, what is mean by green chemistry. So why this is included, I will explain. To minimize the problems of energy crisis and pollution. These are the 2 important things. To minimize the problems of energy crisis and pollution, we have to adopt green chemistry. Green chemistry means what? Green chemistry is an approach to chemistry, which means we have to use the maximum efficiency and hazard should be minimum. So efficiency should be maximum and hazards should be minimum. So the concept of green chemistry is given by the scientist Polyesters. He is known as the father of green chemistry. So 1 mark question will be asked on it. Remember, who is called as the father of green chemistry? So remember this name. Paul Anastas is called as the father of green chemistry. And the definition may be asked for exam. So what is the definition of green chemistry? Listen carefully and concentrate carefully. I will explain. This green chemistry is the use of chemistry. Green chemistry means it is the use of chemistry for pollution prevention by, say, green chemistry is the use of chemistry for which purpose? For pollution prevention. And how? By pollution prevention by environmentally conscious design of chemical products. See, by we have to design such of chemical products and processes that will reduce the or eliminate the generation of hazardous substances. So in one sentence, what is mean by green chemistry? Means green chemistry, it is nothing but to yeah, what you can say, to minimize or to prevention pollutions. So pollution should be prevented, and for the prevention of such pollution, we have to design some chemical products which are efficient and which should which chemical products, and that processes will minimize the hazardous effects or hazardous chemicals. Byproducts will be reduced. So this is the green chemistry. Then to reduce this pollution or energy crisis, there are 12 principles of green chemistries are given by this Paul and Estes. So what are these 12 principles, and what is sustainable? Before the principles of green chemistry, I want to explain what is meant by this sustainable development. Sustainable development, I think you know this word, because I think in 10th standard and 9th standard also this word is included in biology or environmental science. So what is this green sustainable development means? We can achieve the sustainable development by adopting these 12 principles of green chemistry. And what is sustainable development? Is a development that meets the needs of the present without compromising the ability of future generations to meet their own need. So we can achieve the target of this sustainable development. Sustainable means in all time the development should be same. So by adopting these 12 principles of green chemistry, we can achieve the target of sustainable development. So this is one slide I have prepared for the 12 principles of green chemistry. I will not explain this slide. For your understanding purpose, I have prepared these 3 slides, but I am explaining this slide. So these are the 12 principles of green chemistry. First one is waste prevention. So already you know the definition of green chemistry. Green chemistry is nothing but to minimize the pollution by designing such type of chemical processes or chemical products which should minimize the pollution. So in first principle, what is this first principle is a waste prevention, means we have to create less amount of waste. Then atom economy. This atom economy means percentage of atom economy. Whatever the reactants are used, 100% if these are converted into products, then atom economy will be 100%. So the maximum value of this atom economy is always 100%. Means whatever the reactants are used, if 100% these are converted into products, then it is called as atom economy is 100%. So we have to design such reactions or such processes which is having maximum atom economy. Then number 3 green principle is less hazardous chemical synthesis. We have to develop such type of chemical synthesis which are less hazardous, means which are less dangerous, means hazardous chemicals are not used which are very harmful. Then number 4 principle is designing safer chemicals. See, here the symbol of this danger is shown here. So what is number 4 principle? We have to design the safer chemicals which are safe to use. Then number 5th principle is this one, safer solvents and auxiliaries. We have to develop or we have to use these safer solvents, so the pollution will be less, and we have to develop such auxiliaries which are safer. Then 1 minute is remaining, so I will take a quick then design for energy efficiency. What is in the 6th principle of green chemistry indicates we have to design the energy efficient products. Then number 7 is use of renewable feedstocks. In this use of renewable feedstocks, we have to develop or we have to use this feedstocks again and again, renewable. Then number 8 principle is we have to reduce the derivatives. All these principles I will explain one by one in tomorrow's lecture. Tomorrow is Saturday. There are 2 extra lectures, and on Sunday also there are 2 lectures. So the next number 9 is catalyst, number 10 is